So the nice thing about the lights being off and everything, if this sucks, you can just take a nap. It'll be really perfect right in here. So hi, I'm Zane Lackey. What my background is that for the last 3 years or so, I built and led the Etsy security team. And I left there a couple months ago to co-found a new company called Signal Sciences. But really what this talk is my time at Etsy and really lessons learned out of building and running a security team. Really, like, what would I have loved if I could have sat myself down on day one and told myself, hey, here's a bunch of painful lessons you're going to learn, without the painful lesson part. So the one background slide, which is also the agenda slide, is really how have things changed for us as security teams? Because I think a lot of really fundamental ways in the ways in which we built and approached security and SDLC and all those sort of things has really changed out from underneath us. And the first is that code deployment is now really near instantaneous. The merging of development and operations, this is me trying really hard in a single bullet to not say DevOps, but that's exactly what this is. The merging of development and operations, so ops dev, if you will, it really means more people with production access and more people with the expectation of access to systems that maybe in the past that wasn't really there. And then the final thing is that on the attack side, and if you just saw Brandon's talk before this, I think this really hammered this point home too, was that cost of attack has significantly dropped. Right? The amount of tools that are out there that make it really easy and effective for people of really all skill levels to be able to use automation and attack capabilities out there has really gone to almost zero in terms of cost of them. So this is also kind of the agenda. First, I'm going to talk about how do we approach security in kind of continuous deployment and instantaneous deployment in a very frequently deploying architecture. Then I'm going to talk and give like a little bit of a case study on how you approach trade-offs when you're doing kind of DevOps and that sort of stuff of more people with production access. And then the section which I'm not going to get to at all, which is around bug bounties and attack simulations and all of that, because this is totally a 45-minute talk in a 25-minute slot, and I can only talk so fast. So if any of this stuff is interesting, or you have extra questions, or you want to talk on the bug bounty stuff or the attack simulation stuff, I'm just going to go outside after the talk, and I'm happy to stand around and do questions, and we can just talk as much as we want on that. So, near instantaneous deployment. I made a highly technical chart for this of what deployment used to be, which is where you would shovel the bits onto the bit cart and it would take off down the Oregon Trail. And depending on how many times it forded the river or got cholera, it would arrive in production at around 18 months or so. And depending on what sort of environments you're working in now, this is either kind of funny or painfully funny, depending on how often, right? How many people in here are on like a order of magnitude of months to deploy right now? Like a 6-month, 8-month release cycle, something like that. It's cool if you don't want to admit. All right, thank you. People are on weekly. How many people are on weekly? And then daily. Cool. How many people don't deploy code at all? They're just breaking code daily. All right, cool. Got it. So what's this shifting to? I'm going to give examples out of Etsy because I knew Etsy really well, but really treat Etsy here as a placeholder, which is that what we're moving to is very rapid release cycles. Etsy has like a case study here, releases on average 30 times or so a day to prod. And that's not 30 commits, that's 30 pushes to prod. So each push to prod may contain anywhere from, let's say, 5 to 8 different commits. And then what you're really shifting towards there is this constant iteration in production, where normally we would do tons of iteration early in development cycles, and just be during development, okay, let me try out this feature, let me try out that feature, okay, it went to QA, okay, QA hated it, so let me change that, all this. This is now done live, right, which, I missed a perfectly good Bill O'Reilly, we'll do a live meme there, but this is all done now much more in production. And so the three things that kind of make this possible from the highest level are things like feature flags and ramp-ups and A/B testing. Everyone kind of calls feature flags and ramp-ups something slightly different. Everyone mostly calls A/B testing A/B testing. But what this is for feature flags, think you wrap a block of code in a flag that says, the flag says, if I'm turned on, then execute this code. Execute everything. Think of just a giant if statement. And then the reason that you do this is you push that out to production, and now you start making commits into that block of code while it's turned off, while it's called flagged off. And so now you're actually able to push code live to production that's not actually executing in production there. And then you start doing what are called ramp-ups, which would be, okay, now for this block of code, okay, release it for internal users only. Well, first, maybe even just the whitelist of the developer or the development team working on it. Okay, now when they hit production, this code actually runs for them. Okay, now let's ramp it up for all internal users. Okay, now let's ramp it up for 1% of our traffic. 5%, 20%. This is one of the things that is sometimes happening when you go to like a popular site and you get a page that is displaying differently than your friend. And it's on the same page and you're like, wait, why? Oh, I'm getting this new feature and you'll probably get it later today or something. That's either a ramp up where you haven't rolled it out to 100% of traffic yet, or it's A/B testing, which is where you're saying, okay, let's do this test. Let's make 2 versions of this page and let's give 50% of our traffic one, 50% of our traffic the other, and let's see who buys more widgets. Okay, I like number B, or letter B is like the group that actually bought many more widgets. Let's go with that as our design. The point of all of this, and you could talk on all of that forever, is that we're moving towards this all being done live and in production, and that what allows you to do this is really that you're deploying often. So what does security look like? This is a technical diagram of my face on day one, which is, doesn't this sound terrifying, right? Isn't this, okay, now we've always thought of security and application security in general as kind of a gating function, right? That when we're doing waterfall and we're saying, okay, it's gonna go through design phase and then implementation phase and then QA phase and then security testing phase and then throw back in the bugs from that and do remediation and then go live, right? And that's 8 months to 18 months, depending on where you're at. Doesn't this mean that now all of that goes out the window and everything goes into production and security is never going to get to see anything? And the reality is that it's really actually, I've come around from the complete opposite there, right? I've now come around from like being terrified about that to now drinking the Kool-Aid and standing up here and dispensing the Kool-Aid on it, which is that this actually makes us safer. My laptop disagreed and tried to throw itself from the table on that, apparently. Okay, so the biggest thing to learn here, and this was my big learning point on this, was that vulnerabilities occur no matter what your development methodology is. It's not like, oh, okay, well, I'm doing waterfall, so no more bugs, we can all go home, right? And it doesn't matter that, oh, we're doing continuous deployment and no more bugs and we all go home. The difference is that now there's no longer such a thing as a out-of-band patch, which for any of you who have lived through development at organizations where you have to do out-of-band patching, this is amazing. The big thing here is that, and I've got a good example that I love here, which is like one time when we were talking to a vendor and we had dropped them some bug that we found in their stuff and we're like, hey, you guys need to get this fixed. And they're like, absolutely. We're going to rush an emergency fix. It will be out in 6 weeks. Which becomes even more funny when you realize it was like a reflected XSS in the search box. Like it was not a massive re-architecture, it was some input validation. The big takeaway of kind of this entire section is the fact that vulns occur no matter what we're doing, and that the ability to react quickly is actually the state that you want to work towards. That when you have a vulnerability, like take this kind of almost contrived example of some very easy to fix vuln, and it takes you 6 months to go out, or 6 weeks to push a fix, and that's we're dropping everything emergency fix. That's what you're trying to get away from. You're trying to get to, oh, a security fix? That's just another deploy. We're not waiting until, we're not going to rush things up from the 8 months that it normally is. We're just going to go push to prod because we already pushed to prod 30 times a day. Like, it's not a big deal. The other side of this is what makes continuous deployment safe. So there's the ability to react quickly, and then there's the ability to monitor and instrument and have detection capabilities. And these are the things that you have to do. What's really nice here is you need these capabilities to be doing continuous deployment anyway. Security didn't just show up and say, hey, we need a wall of graphs, and everyone's like, what's that? You show up in continuous deployment, and you're like, hey, we just need an additional graph on the wall of graphs over there. I really like the comparison to modern aviation and airlines, right? You don't need any of those graphs or dials to be able to fly, but you probably want them when you need to land, right? You don't need any of these graphs to push to prod, but you kind of need them to make sure that you didn't just break everything, right? If checkouts just dropped off a cliff after you pushed to prod, that's probably a problem. And backing up, you need to have that graph about checkouts in the first place. This same culture that becomes kind of inherent in continuous deployment around continuous monitoring and metrics and instrumentation, you really want to latch onto that for security as well. You want to take that and just run with it. And the biggest lesson learned out of that is surfacing security info, not just for your security team, but for everyone. Right? You don't want, here's like the example, that's the dashboard screenshot. The key is Grumpy Cat and Lens Flare. When you combine the two, it really works quite magically. Thank you. Oh God. No, thank you. Wow. 15-year-old me is real. Oh, and it's hot too. That's, wow. A gentleman and a scholar. Oh God, no. Oh. Can I just break it? Shiv myself there? All right, I'm gonna casually sip this fine beverage. Oh yeah, yeah. All right, that's all right. Okay, so the biggest thing is surfacing security info for everyone. You don't want this dashboard just on like an iPad in your security team. You want it going back here. You want it back where everyone can see it. And what you're really the underlying motivation here is you're trying to move security from being an abstract concept to something that is very concrete in people's minds. My friend Nick Galbraith, I thought, put this really succinctly, which is that don't treat security as a binary event. And what he meant by that is that in most organizations, security is very easy. Either Brian Krebs just called us and we're putting out reports and we're answering quotes to the New York Times about why our database is on Pastebin, or we're not doing that, right? We're either owned or we're not owned. And the reality is much messier and much more complicated than that. And that's really what you're trying to do with things like this, is surface that, these particular graphs don't illustrate this point as much, but when one of them goes through an order of magnitude bigger than you've ever seen, it's one thing for your security team to sit around and be like, okay, well, someone's throwing more SQL injection at us than we've ever seen. Cool, it's Tuesday. It's another thing that when development group walks by and goes, whoa, why is that graph going through the roof? And you're like, that's people looking for SQL injection right now. It really flips from the abstract, I know my code's on the internet, it's going to be attacked, to a very concrete thing with data behind it. Okay, so flipping over to kind of the culture side of this. The mullet is awesome. It's so good. The way in which we get to continuous deployment is by removing blockers, right? When I talked about that waterfall method of you're going through all these different phases and all of that, the way in which we speed that up is we cut out a lot of those and we change the way in which we approach other ones. And that could be, a week-long talk in and of itself. But on security, this is a huge fundamental shift for us, because it means that you're no longer the gatekeeper to shipping. You're no longer the blocker on that. And you've gone from having just the assumption that teams are going to come talk to you to now you need to incentivize teams to come talk to you. And that's a big shift in how we've done business. This is really, we're now thinking about, okay, how do we get people to want to talk to us as security people, which can be an interesting challenge. So I'm going to give like 5 bullets, I guess, on that I thought were useful. The first one is easily the dumbest one. And yet there's a very real reason why it's the first one. It becomes incredibly easy to get really snide with development groups or with developers around code bugs, right? In the same way that when we're all sitting around having beers, like after this, and we're like, man, this one bug that I saw, right? It was the dumbest thing I've ever seen. If that's your interaction with development groups, you get one interaction and then they don't come back, right? If somebody comes up to you and is like, hey, can you do a code review for me on this? And you're like, that has the stupidest vuln I've ever seen in my life. Like, cool, thanks, dude, later. And they never come back. And you not only lose them, you lose all of their friends too, and the rest of their group. So this kind of leads into how do you start to work with teams on this? And one of the biggest ones is how do you make realistic trade-offs? This is another one where I feel that as an industry, historically, we've gone through and said, hey, here's your stack of bugs, go fix them, and then you can ship. And the reality is that when you're shipping far more often now, there's not time to do that. And you need to be able to buy credibility with teams and say that, hey, here's your stack of 10 bugs. Here's the 3 that are really going to kill us. Here's the 7 that if you can get to them in the next couple weeks, cool. And here's why. And that really goes into the next one too, which is coherently explaining that, not just you've got input validation weakness here, or you've got, an output encoding problem there. It's saying, hey, here's what this problem is, and this is why it actually matters, right? If an attacker does this and this is the data they're going to get out of it. And now it's not just it's an input validation, which I know is something that's supposed to be bad, and there's a box with a 1 in it popped up on the screen. It's that this is what actually an attacker is able to do with it. And then, again, another super dumb one, but super effective, is figuring out how you reward communication with your team. This is kind of one of the inherent things in bug bounty programs as well, is you're trying to figure out how to reward communication with your team. In our case, we would do a lot of gift cards, actually, internally. So we would give Etsy gift cards to Etsy developers or anyone internal who came to us with issues like that. And what we were really trying to incentivize were people to even feel comfortable enough to come up with their own code. Be like, hey, I'm doing something here. I'm trying to protect this piece of user input or this user data. Here's what I tried to do. Is that cool? How does that work, right? And you're no longer you're going to get in trouble for that. It's you're going to get a high five and a gift card for coming up to us about that. And you better believe every one of their friends, when they go back in there, everyone that sits around them just heard that they got a gift card for talking to security about bugs. Like, you just got a 10x multiple in terms of people talking to you. This is probably the most controversial one, and it's really much more controversial as you scale, which is there's kind of been, I've seen two approaches in the way security organizations do this, which is as you're using tooling or pen testing or anything like that, it doesn't really matter how you get a stack of bugs, it's what you then do with that. And some organizations take that and you ship it directly to the development group and you say, cool, here's a big stack of things, figure it out. And the problem is when you ship a report with 1,000 bugs in it, and the first 15 they get through all are false positives, they're never listening to you again, right? It's like, you just wasted several hours of my time on stuff that I'm not the security expert. You're the security expert, and you just gave me 10 million false positives. Like, are you kidding? We're done here. The trade-off here, and what I feel you want to do, is take that hit yourself as a security team. And the trade-off that you're making is you're saying, I'm only going to go to development groups with real issues. The trade-off being that you feel like you're making a trade, and I don't think you actually are. You feel like you're making a trade that you're inducing time lag to when that's going to actually be discussed by the development team or when they're going to look at it, right? You're feeling like, oh, if a development group that's 10 people and I ship them a whole bunch of bugs and they go look at it, they're going to look at that immediately. Versus if I have to look at it and I've got 2 people and we're super busy, we're not going to get to that for 2 weeks to be able to dedupe everything and take out the false positives and give it to them. The problem is that the moment that you send some big report to some group, they just add an email rule that anything that you send them with an attachment just goes to spam, right? That's the reality. You're not actually making a trade-off there. And so when you only go to development groups with real issues, you're earning that credibility again as well. And then the final thing on this is scaling via your team leads. So this was something that we had a lot of success with there as well, which was the rest of engineering is hiring faster than security is hiring, just inherently. So how do you get it? How do you not lose the battle of, okay, even if you got everyone that's in engineering today to buy into security, in 6 months, there's going to be a lot of new people. And how do you not lose that? The way you do it is go find your team leads, whether that's a team manager or the senior technical person on the team, or just the person who doesn't have the title but everyone looks to for technical guidance. Go get them bought in and go work with them. Go buy them beer, honestly. Like, go use everything at your disposal on this. So that when somebody new joins their team and the new person is going to go push to prod for the first time, and that senior person, whoever they are, says, cool, what's security have to say about it? And the new person's like, well, why would you ever talk to security? And they're like, no, we actually do here. Go run it by them and see if they have feedback, and then go push to prod. Now you didn't have to make that conversion yourself. They did it for you, and you can actually scale. Okay, second section, a little quicker. So access controls in startups are great, and the dirty secret is I say startups here. In reality, just replace startups with everyone. Everyone can access everything, and so as organizations grow, whether it's regulatory or compliance or just trying to shore things up, there's going to be pressure to start to institute access control policies. And the biggest thing to remember here, and I'm going to give like the methodology at first and a specific example of it, is don't take away capabilities. Take away access, but not capabilities. People aren't just SSHing to prod for the hell of it. They're doing it to get their job done. So what you need to do is figure out why they're doing that and not take away, you can take away that access, but not what they need to get their job done. So the methodology is figuring out what that capability is that they're trying to do, build an alternative way so that the step from 1 to 2 is the big investment and the big jump. Build an alternative way for them to do that in a safe way, then transition the organization over to that safe way, and then alert on any usage of the old unsafe way or shut off access to it or whatever you want to do from there. Maybe add two-factor to it and some other thing, whatever you want to do at that point. So one of the most common ones I've seen is SSH access to production systems. So I will take a drink for the 5-minute warning. Oh, that's magical. Okay, so why do people SSH to production? There's a lot of reasons. One of the most common one is developers do it to be able to view error logs, right? Something's breaking in production. Someone filed a bug with like no steps to repro it, and you're trying to figure out what is going on, and you need that data. So the alternative approach is central logging, right? Being able to grab, if someone's SSHing to prod to go view the error log, move the error log somewhere else, right? So do Elasticsearch, Splunk, whatever you want to use. You publicize that new tooling, and then after that transition, maybe you start soft and you say, okay, we're going to alert on any logins that are not by our sysops, right? Not the people that we expect to SSH into prod. Maybe then the next step is shut off access to anyone who's not sysops, or roll mandatory two-factor to everyone, or cut that group down, whatever. The point is you've gone from your attack surface of everyone with that access to now a specific group where you can start to look at and say, all right, now I can start to instrument this and say, if there's only this small group supposed to be using it, now I can alert on anybody else. So that's kind of the chopping point for this. The TLDR is surfacing security info and metrics, not just to your security teams, but to the organization at large. Incentivize discussion with the teams because you're no longer a critical like control point. Things are going to go to production that before you ever knew about them. And you need to incentivize people to come talk to you. And then when you're creating policy and making access control changes, don't take away capabilities. Take away the access and build a safe way to do it. The part that I didn't get to go to, which is about half this talk, is how you start to build feedback loops into your entire program. Right? This is all great that these are different approaches that you have. How do you know what's working and what's not working? There are a number of ways you do that. And the ways in which we do that are through bug bounty programs on the kind of web AppSec side and somewhat on the NetSec side, and then changing the entire way in which has now become a cliche at this point, but changing the way we do pen testing. But really running the 2-second overview of that is when we've said we've been doing pen testing, what we've actually been doing is vulnerability enumeration. It's here's your stack of bugs, go fix that stuff. It's not how attackers actually operate against your environment. They're two wildly distinctive things, and we need to be doing both of those. So you drive up your attacker costs through running simulations on this, getting real data about how attackers actually operate, and using that as the feedback loop into your program to figure out where you should be building better detection mechanisms and focusing more effort. And you guys are awesome. Thanks for coming. So I actually have